This will be the instructional video over Bentel Chapter 4, Problem 10. We're looking at a linear accelerator, and we're looking for a dose calculation for parallel opposed fields. So a dose of 200 centigrade is prescribed at the midplane of the lung. Parallel opposed anterior and posterior 4 MV photon beams are to be used. The field size is 13 by 13 and the SSD is 80 cm. The AP diameter of the patient's chest is 21 cm. The centigrade per monitor unit reference is 1.0 for a 10 by 10 field. For a 13 by 13 field, it is 1.022. So what MU setting per field is necessary to deliver the treatment? And it says to use table 8.2 for the percent depth dose, which I have in the, I've uploaded into the course. So now, as far as what it is that we're going to need here, let's go ahead and kind of draw this out. We're going to have, let's see, we're going to have the dose, and that is going to be divided by the centigrade per MU, the ref, times the area factor, times percent depth dose. We know this one is 1.0. We know this is 1.022. And we know this is basically going to be 200 centigrade because that's what's being delivered, but it's being delivered parallel opposed. So we're going to end up splitting it between the two beams. So what we've got here is 100 divided by 1.0 times 1.022. And the last thing that we have to figure out is the percent depth dose. The question is, what is the percent depth dose? Well, this is where things get a little tricky. So what we're going to do is we're going to go here. I'm going to go ahead and kind of erase through all of this stuff here. I can recreate it. I'm going to go back through. There we go. So what is it you need to take away here? Well, we're looking at, again, using a 13 by 13 field. We don't have a 13 by 13 square field setting up here for this table. Also, we're looking at an AP diameter of the patient's chest is 21 cm. If we cut that in half, which is what we're prescribing to, which is going to be the midplane, it's going to be 10.5. Does that mean that we get to use this line here? Not so much. At least not straightforward anyway. When I uploaded this, I ended up cutting it in half because of certain issues here. So I just want to say that what we're looking at here is going to be somewhere between 1, 2, 3, 4, and 5, the fourth and fifth column. We're going to need a value here between 12 and 15 square for the square field. So we're going to need 1, 2, 3, 4, somewhere between 61.4 and 62.4. Also, we are going to be looking at trying to find a distance not at 11, not at 10, but in between 10.5. The question is, what is that value going to be? In this particular case, what I'm going to do is I'm going to interpolate. And in this particular case, what I'm going to do is I'm going to say, since we were looking at 10.5 here, I'm going to take the average of these two. Since it's right in between those, that's what I'm going to take the midpoint. So when I go through and I take the midpoint, which I'll go ahead and put over here, the midpoint in this particular case is going to be 61.4 plus 57.6 all divided by 2. And if you go through and if you do the math on that, it should turn out to be 59.5. So this value right in here is going to be 59.5. We do the same process over here for these two values in the 15 column. We've got 62.4 plus 58.7, and we're going to cut that in half. And what you're going to find there, I've already done the math for it in Excel, ends up being 60.55. Okay, so I'm going to go ahead and put that here. 60.55. So I've got to find a value here for the depth at 10.5, somewhere between 59.5 and 60.55. Question is, what value in between here am I going to go with? Well, since we are looking at a value for a field that is 13 by 13, and our fields are somewhere between 12 and 15, I'm going to take a third of the distance from here to here, and that's going to be the value that I'm going to use. So go ahead and get my notation thing going here. So what I'm going to do is I'm going to take 59.5, and I'm going to add to that 60.55 minus 59.5 divided by 3. This is the way you do it. You take the lower value here, and then you take the distance between this two, and you're going to cut it by a third because you're looking at 13 by 13. You're not looking for a 12. You're not looking for a 15. Since a 13 is a third of the way between 12 and 15, that's what I'm going to do. If it were a 14, then I would multiply this difference here by 2/3. So by doing this, what do we come up with? Well, we've got the 59.5, so I'm going to take, let's go to $60.55 minus 59.5, divide that by 3. So I'm going to take that and I'm going to add that to this. So I should come up with 59.85. So yeah, that's a bit of a bunch of mental gymnastics here for interpolation, but that's what it's going to end up being. So PDD is going to be equal to 59.85. Again, changing that to a decimal and putting it under the denominator here, it's going to be 0.5985. So let's clear all the drawings here, get rid of that, and then go back to the original problem. So this ended up being, was 100 divided by 1.0, and I should put units on here because if I don't, that's recall being a very bad teacher. And let's see, MU ref times 1.022 times 0.5985. And so the MU's going to be equal to, if I take 1 times 1.022 times 5985. Okay, so I'm going to say here, this is 100 divided by 0.611667. And that, let's see. End up with 163.48, which if you round up, since you can't have a fraction of a monitor unit, it's 164 MUs. So this is going to be a real lesson here in terms of getting the interpolation down to be able to do what you need to do. So I hope that helped, and we will discuss another problem here shortly.